right. Can I have a raise of hands? Who has used Fusion 360 before? No one? Oh, one person? Hey, what's your name in the class? Jeffrey. Jeffrey's in the class today. And so many other people in person. Thank you all for coming. Yeah, so it looks like most of you haven't used this software before. This is great software, similar to SolidWorks or any other 3D CAD software, but the caveat of this one is the fact that it's cloud-based, so very portable, and it has basically everything you need, and I love it. So here we have just the main screen page. I don't know why is yeah, this is the main grid where you're going to do all your drawings and making all your cool things. Yeah, we use this cube up here. Also, this is a follow along. Do you have Fusion installed in your laptop? Anyone? Jeffrey, do you have it on your laptop? Yes.
Nice.
Oh, more people. Are you here for the CAD workshop?
I'll have a look, yeah.
Okay, you can just sit down and listen to what I'm saying.
I love it. You put the stage there for a long time. I know.
Okay, guys, please stop interrupting the class. Please keep the levels down. All right, let's get started. So what we have here is our workshop space. We're mainly just going to be looking at kind of like what projects we're going to be using. So we already have one here under 3D CAD Workshop. I need permission from the project administrator. I thought you made this way. Oh wait, I made this way. Oh, no, but I made a project inside it. Should email there. Usually you'd go to new project, create project. I'm going to call this test because we're going to get access to this one that I made on my laptop. And then you can use this, and all your files and stuff will be put into this project. All right, and now I'll kind of give you the basics of it. So you have your grid, and just these settings. If you don't want the grid, snap the object. So we'll go into more details like this later. And there's also like cool view like dark mode. But that's really up to you. It is, but you know, you want to be comfortable while you're making stuff. So I'm gonna just switching it on. All right. Oh my god. Okay, let's actually get started. Can I get a suggestion from the chat? What do you want to make today? We're going to split this course into two parts, okay? There's going to be, the first part is just going to be basics, very beginner level basics. And then the next part, I'm going to be looking at especially what electrical engineers will do with Fusion and how we can import, specific components like motors, motor drivers, Arduinos and things like that, and how you'd model around those certain specific components. So for the first part, we'll just give you the basics overview of how to model and how this thing operates. So just give me an object, something random. Okay, a bottle opener. See, that's a pretty good one. And I'm going to make it a fancy bottle opener so I can show you all the little gizmos you can do with Fusion. Okay. All right, so let's get started. So first thing you can do is you can, okay, we'll use this test for now. First thing you want to do is you want to save your project. Make sure you save it. So Control S, or just, yep, there you go. So let's save this. Let's call this bottle opener. ELSOC. Okay, if you 3D print this, it probably won't work because, you know, it's plastic, but you never know. Yeah, put a coin in it or something. If it was very well engineered, not like how I'm going to do it, it'd be good. All right, so modeling operates on 2D planes. Oh, you start off with 2D sketches and you would convert them into 3D. Like, for example, you can draw this box here with a little curve in it, and then you can use this tool, the extrude tool, to make it into a 3D object. That's pretty much the basics of all you need to know. So we click create sketch, and we have options of which plane we want to start drawing on. So let's draw on the bottom plane, okay? And what does a bottle opener look like? Well, not sure. Actually, I do know. Let's go on Google to see a bottle opener. I have one in mind, but I want to make sure everyone knows what it looks like. Bottle opener. You know, have you seen the ELSOC? Okay, so look, we've got a bunch here. I was going to make something that looks similar to this, right? And that's pretty simple if we have a picture for it. But I'm just going to go off my brain and think about what this looks like. All right, so and if you think about the extrude tool, it's kind of making a 2D surface into a 3D by pushing it one direction. So I'm going to make this face here, this funky looking thing, and then extrude it outwards. And then we can add more stuff to it to make it cool. All right, so here you have your kind of tools to draw. Maybe we'll start with a rectangle and kind of like carve out what we want. Okay, so how big is this? Is our area of our rectangle going to be, or our whole bottle opener? Let's use a center rectangle instead. Tell me if I'm going too fast or anything like that. So 20 millimeters, that's like 2 centimeters. So that's obviously not that big. So you can use your fingers as a reference. That's what I like to do. 2 centimeters, 3 centimeters wide, 6 centimeters long. I think that'll do. So let's try that. So you can type in manually 60 by 30. Maybe we'll make it 20. Yeah, let's make it 20. And there you go. So this is going to be the size of what our bottle opener is going to be. And looking back from this picture, let's use this picture. Oh, maybe shouldn't. I want to open the picture in new tab. I feel like you always look like an old man when you like using a computer in front of people. Okay, so you have this circle part here, you have this top part, and you have this little dingling that comes around here. So let's focus on the circle part and this long part first before we go into the complicated part. So we need to make a circle here. So there's a bunch of ways to make a circle, and there's a bunch of ways that can help you make a circle. So maybe we'll try the 2 tangent circle, because I can use this line and this line to make a circle here. Okay, so boom. Make sure to click on the lines, and you can see that circle is similar to the circle that we want. We'll just make that 5. And we can also make the next part. So we have this circle here, and now we want to make kind of like this shape here. So let's do that. I'm just going to start from the top here and then bring it down maybe like 2 millimeters and then just stretch that across. And you can right click and then press OK. for this little wheel here. Very useful when you're just going on the fly. Okay. Now that's pretty much that whole bit here. It doesn't go all the way down, so maybe we can cut it off a bit. And that's pretty simple. You can either just draw another rectangle here and just like, let's say 10 millimeters, and that's the point. You can see here that I'm kind of drawing, but I'm leaving all this construction line work happening around it. This is all right because there's some tools which allow you to clean stuff up, like the trim tool. And it's kind of like an eraser. If you press and hold on this, you can kind of erase lines like that and see it's kind of morphing into kind of what you want, right? So that's how my drawing style works in this software. Okay, the next part is that weird, complicated looking thing over here. How are we going to do that? Well, let's break it down. There's just another line with two little forks that come either side, like a crab hand. So let's just put that here. An easier way to do this is actually to have a picture up, a 2D picture up, and then just tracing the picture. But you know, we like to do things hard, so we're doing it harder. All right, so bear with me while I draw this thing out. Okay, I'm gonna show you some cool tricks. So make like a really boxy version of it. Okay, let's put this out. And the cool thing about Fusion is that you can kind of like edit things on the fly. Like for example, you can do stuff like that. It's obviously not doing the thing that I wanted to do, but it's okay. Let's bring this out a bit more. Maybe try bring this out a bit more. And we'll put the big block here. And put a block here. Like that. Does that kind of look like what it looks like? Yeah, okay. And now that we have kind of something that looks like it, we can just trim off the excess stuff so we're left with like a single shape. This is probably one of the more satisfying parts of CADing for me, is just erasing everything that we don't need. So I'm just going to get rid of all this stuff. And we're left with something, and even the inside lines. Boom, boom, boom. Oh, too much. Okay, maybe that was a bit too much. Okay, let's leave it like a key. Let's just make a key. All right. So just how does that sound? Maybe a key is better. All right. So from this point, if you got lost, or if you did exactly what I did, it's okay. It's just going to be the same process. But let's just keep it simple. You're right. So just put like just make a rectangle at the end here, just like that. And you'll be fine. And add a circle here as well, because why not? All right. Just let me know, chat, if I'm going too fast, please, or if it's too complicated. It'll get more complicated. All right, let's trim now. Let's get rid of this stuff. So we just want this key looking thing. All right. Get rid of any lines that won't be necessary, or you can keep them in. It's just for simplicity's sake. So now we have kind of like one unified looking paddle kind of thing. Okay. All right. Some things you can do is use the fillet tool. So let's say I want to round these corners. So you can use this tool and you can round it like so. This is what I was going to do to that other part. But you know, just keep it simple for now. And you can kind of use that to kind of get something nice looking. But we'll go into more detail about like that. So once you're happy with your 2D shape, like how we've made it here, you can press finish on the sketch. And we can highlight this shape and press the extrude button to make it 3-dimensional. So we'll bring this one up and ooh, it's like bread rising. Let's make this 6 millimeters. It seems about right. Or you can make it as high as you want. It's up to you. And there we have our bottle opener that doesn't work. So, woo, but you kind of get the gist of what we're doing. But let's actually make this more work by making another face. My grammar is great. That's why I'm an engineer. So as well as making shapes, we can use sketches to subtract from existing 3D objects. So if you missed what I just did, I selected this face and I pressed create sketch. So we can create sketches on any surface, such as the one that we just made. And you can use it to kind of cut out. Imagine you're just carving things and molding things. So again, let's just make a little cut here. The grid is really nice for you to just, you know, have some nice clean cuts that are pre-existing. So I'm going to go 10 and you can just bring it out. I know we're going to cut through this, so you can pretty much go as long as you want because we're not making anything, we're just cutting. Okay. And let's just make another box up here as well. Why not? All right. And once you've done that, we'll finish the sketch. And we're left with these 2 boxes that are lying on top of this surface here. Now what we can do is go back to the extrude. You can select before or after you press this button, doesn't really matter. But let's select those surfaces. And instead of bring it up, we'll bring it down. So when we bring it down, we cut through the object. Right, and you can kind of determine the operation it does through right here as well. So if you didn't want to cut and you wanted just to join, you could actually click join and it does that. You can even intersect it, but I've never used that before. You'd have to be a bigger brain. New body if you just wanted to make a completely separate entity, but right now we can just cut it. So let's go. So now that's looking a bit more like a bottle opener. And yeah, there you go. Okay. Let's show you some more tools before it. But that's pretty much the basics, and you can go wild with just pulling and pushing these components like so. Pulling and pushing shapes like that. But let's try some other kind of techniques. Okay. Let's say I wanted like a long handle off this for some reason. Maybe it was like really hard to pull open that bottle lid, so you needed some more torque by it. So we're going to add a long pole above this, but it's going to be like tapered with a handle. Okay. How would we do this? Well, we can make a circle here. Damn, this is going to look ugly as. But we can make a circle here on this face. So create a sketch on the top here. The Loft Tool, yeah. Let's make you can make a 4mm circle anywhere. So I'll make one here. And press OK. All right. And I'm going to show you another tool called the Loft Tool. So the Loft Tool looks like this. So you can kind of merge any shape you make onto another plane that you've created. But how do I make a shape in the distance from this place? There's no surface I can touch. Well, oh, my Fusion is lagging. Oh, no, it's not. It is. It's not. You can make this offset plane here. So you'll click on this surface and you can pull and make your own plane just like so. So let's make this like 20mm away. Perfect. Yo, why can't I grab my box? So let's create a sketch on this plane that we just made. And we can make this any shape we want. Maybe let's make it a square instead of a rectangle, instead of a circle. And just put a square anywhere. You could make it huge, you can make it small, or you can just follow me and just make it the same size as that. And let's see how it works. Finish that sketch. Yo, I can't like rotate. You can use these other tools as well, like the orbit tool to kind of rotate as well. And you can use the middle mouse button to pan. Some cool facts. As well, you can kind of change some of the perspective of views. I like to work, so orthographic versus perspective. I don't know if you know much about that, but perspective will give you more of like, it's shrinking in the background as it gets further away, and orthographic, it stays completely the same no matter how far away it is. So it's kind of like a mathematical view of the world. I like to do a mixture of both. So when I go and click on one of these, why is this plane? I don't know why this is not working. But when you look at a specific face, it changes it to orthographic. Anyways, let's use a Loft Tool. And we're going to make this, so that's profile 1. You don't need rails. And that's profile 2. And boom. And you just press OK. And there you go. You've made another thing that's part of it, of this thing. Woo! And you can also do, you know how we did the fillet in 2D? We can also do it in 3D. So we could even make this a bit rounded. Obviously, we've kind of made it weird because we have this weird shape. It's not very generic. But yeah, you could round these edges. You could even use another tool called the Chamfer Tool that could shave edges instead of rounding them to give another cool effect. And you can select multiple edges, just like that. And really, these two tools will make your object look more complicated, even though it took like 2 steps to make. Like, for example, this is looking pretty crazy already, right? But there we go. That's kind of like the basics of everything you need to know. Other tools are cool, like the Revolve tool. But all this stuff you can really just play around with and then use your creativity to kind of make. But that's kind of like the basics of it. Now I'm going to show you what, as an electrical engineer, what you would use this whole software for. Hopefully, Tony's computer has been accepted into the project that I made. Let's see. Did it get deleted? Where is it? Oh, here it is. We're in. Okay, so I will share this with you guys. This whole thing. So when you put your emails in, or if you've registered for this, we'll put your emails in so you could get this whole everything that I'm doing here, as well as this one. I'll add you in this one as well. But this pack right here that I'm showing you guys, I will put the zip file in the chat. And all I did was go online and search up these very basic electronic components and download them off the internet as 3D CAD files, and they're all to scale and everything, so it's great. So you just have a 3D model version of things that exist in real life. So let me just put it in the chat. You guys can have a sip of your water or something. Okay. All right. So I put that in the chat now, so you can download that and import it into your projects that you've made. In the meantime, while you do that, I'll show you some more steps. I'll just create a new project in here. So remember to save your work. It's also a good point. Okay, I'm going to call this all right. I kind of have a picture already of what I made on my other computer, my personal computer. I'm using Tony's right now. Just let me know when you've imported all those files. So you can go to you can press file and press upload, and you choose that thing that I sent you in your downloads. Download that, and then plop it in your and just highlight all those Fusion files, and then just it'll give you a prompt to upload, and you can just upload them. Oh. Okay. So while you do that, let's move on. So what I'm going to do now is I want to put all these objects in just one project here. The way I did it last night was just opening up them all individually and then just copy pasting the component in. There's other ways to do it, but I just haven't. It didn't work for me last night. So let me just try it again. So let's put the Arduino in. Maybe it was something a bit lighter.
So, yeah, would you ever put the file in the chat?
Did the zip file not work?
I'll say it in the chat. You might just be that use join.
Let's see. No, I can see it. It's this one right here. Can you see it?
I think it's not joined after it goes.
Oh, right. Jacob can see it. Are you in the meeting? Oh, you are in the meeting.
Yeah.
How do you make it so everyone can see the chat?
What do you put it on?
Do you want to just send it again? Yeah, I'll send it through again. All right. Did you just join? All right. There it is. Should be uploaded. All right. Oh, it worked. Oh no, it didn't work. Okay, now we just open every file, and you just want to. I've already made it all into one component, but when you download it, it might be bodies, might be components, and whatever. But it's easier just for this example to have everything in one little selection here. So I'm gonna just copy and then paste new. And for you guys that want to know what we're making, just gonna make a little robot, little like car robot thing. Yes, I have a picture here on my other computer. I'll send it in the chat for you guys to see what the final product will look like. But in the meantime, yeah, just click open every file and then just copy and paste everything in. So you can open these, wait for it to load. I've kind of stripped down the file to make it easier for your computer. So you go copy, paste. Do you guys know how to extract zip files? Have you done that before? Oh yeah. Go into Fusion and then go to File, Upload, and then you select those extracted files through there, and then you can select them all, and then just press Upload to upload them all. Why does my box not work? This is kind of annoying. So your battery pack. Yo, how do I escape this? This might be all separate, but what we can do, see how they're all separate components, which is kind of annoying. I want them all to be one component. What we can do is we can make a new component, and yes, just press OK, and you'll see another component thing come here. We can highlight everything in this pack here, and then just bring it into here. And now everything is inside here, and we can move it all. Jokes. Now we make this a rigid group, and now everything could be able to move together like that. Ooh. And what we can do is we can copy this component like how we did for the other ones. Copy, and then just paste it in. Oh, where'd the other one go? Just can't see. Just let me know if I'm going too fast or anything. That we've got plenty of time. We have this until 4 o'clock. So yeah, you just have to click on them all. That's what I was saying before. I was trying to do it, but it didn't work. So this is what I resorted to. It's not that bad because we don't have that many components, but it is quite annoying. But once we get through it, it's all right. And most of these objects, actually, these wheels and motors, you can buy it from the CAD store. Shout out to Alex. Are you still in CAD, Alex? Yes. Copy. Yep. Paste. I think that's the last one. Let me just help Jeffrey real quick. After I open this last one. Okay, maybe not. Is your file crap as well? Thanks. About statement to replace. Yeah, that's probably why. Yeah. Oh, is that just broken? That's all right. Well, if you do get it working, you know, you can just work on it at home. But you're always going to run into these issues because it's like software with software shit. But it's all good. So I have one more to upload, which is the Omni wheel. You could always, like, if you're really impatient, Jeffrey, you can just restart the whole thing and then re-upload it and see if it works. That's like the impatient solution. That's what I'd do. Copy. So if you've done Eng 1000 like me, oh, by the way, guys, I'm Miguel. I'm a 4th year. I used to be the president last year for ELSOC. If you didn't know, swag. And I'm back. Anyways, so we have all our components here. All of them you've probably seen before. But I want to let's start putting them together. Have everyone imported the files? Just raise your hand if you've somewhat got the files in and there's no problems. Put it in the chat if you have problems. I'll take it as you're still going, but I'm gonna. Okay, I'll give you until 3 o'clock. We can have like a little break, and then at 3 o'clock I'll get started with putting everything together. How's that sound? Sounds good. Can't go for 2 hours straight. It's a bit straining. I need to figure out how to make my box work again. Have you seen this before? Why do I haven't used it? I've never used this. Only I've used this. Like the one my rotating box doesn't work for some reason. Yeah. Okay. Did it work? Yeah. Yeah, see, my method always works. Okay, no worries. It's recorded, so no worries. Why is it busting? Yeah. Do you? I guess workshops do probably better. Exposed to saying, but I'm not things. Yeah. Well, we had 5 buildings. And there are solar shops that you can book those by me. So that's it. You book it if you get the badge, but also isn't it? It's not just going to make the space under the electronics badge. How are we going so far, Tony? Am I going too fast?
I'm not sure.
I'm sure. Are you learning? Is it engaging? Maybe.
Yeah, probably. I wasn't following the first half hour because I was doing
Okay.
sign up stuff.
Are you engaged? Do the engagement levels need to increase?
Possibly.
Okay. No, it's all right. It's harder for the people online because you're not communicating with me. Please talk to me. I love you.
It's a
Yeah, true. And if you want to move things around, always we can right click here. This is all your components right here. And you guys have to turn them on and off if you want to see them or not. I don't want to see you. Like this one is like randomly been turned because I didn't turn it all the way around, but I can move it still. Oh my God. Can I have some water? Do you have water?
Oh, there we go.
Thanks.
Yeah, what would be the benefits of having a CAD model on the latest experiments?
Presentation.
Sure.
Very easy prototyping.
Yeah.
That's basically it.
Yeah.
And renders. I'll show you renders towards the end. But like for example, my 3117 or 2 even was it 317? What was that one?
Yeah, it's been a
317. Even that little project. What's the second year group project? Eng 2000, Desert 2000. We had to make like that train system.
Yeah.
That's what we had to do. And I just made a train in CAD with all the features that we were implementing it.
Yeah.
And we just got all the marks for presentation because I went out of my way to make a CAD model for this train. And because I just wanted to do it because I like doing CAD, right?
Sure.
And they just loved it.
I think that's enough.
But if you want to have if you're a hobbyist, if you have a 3D printer, I know you can 3D print almost for free here,
Yeah.
I think. So this is if you want to make like good electronic bodies and things like that for cheap without having and with a lack of labor with good detail, this is the best way.
Yeah.
So
you chuck a box around all this sort of thing. Yeah, maybe would you be able to show us?
Yeah, I'll show you a picture. And that's in the middle of what I was doing.
You know, are you familiar with 3D printing? Like, how to go from this?
Yes. Yes, but I probably can't cover that in this part right now.
Maybe we can look at another one.
Yeah. So this is an example. I'm about to put it in the chat because I have it on my other computer. But hopefully we'll get to this stage when the picture comes through. I can show you guys. So right here, this little photo, this is what we might get up to if we get to it. So this is the robot. This is like a little vacuum cleaner thing, but without the vacuum. But you can everything's removable and things like that, and you can kind of design. You can explode it out as well, yeah. But I'll kind of run you through everything, and also the components inside will have send another picture through. They're kind of the body is form fitted to house all the components, if that makes sense. So let me just. and the wheels can turn. You can also animate with all this stuff as well. That's another part of the presentation. So like, for example, inside it, inside it, you can see that we have, like our Arduino and our motor driver and our battery and our motor. I've kind of like modeled a spot for it to sit in nicely, and you can either use glue or don't use glue or use blue tack, but even for these parts, I've kind of like elevated kind of the surface so it's not exactly stuck on, but it won't rattle around and stuff like that. It'll just kind of sit where the screw hole is supposed to be, but you can take it out easily like that. Or if you wanted to incorporate screw holes like this one over here with like a washer and nut kind of situation, you can totally do that as well. I've tried 3D printing screws and stuff as well. It's not a great, it works, but not really.
Yeah.
But yeah, it's always an option. But for right now, it's 3 o'clock, so we'll get started into starting this process. I'm gonna just fix up this battery because it's a bit weird. So again, if you want to move objects, I like to, instead of clicking on the face, I like to click on the component here and move it like that. Jeez, where is my thing? Wait, let's see. Okay. My cube isn't working, so I'm going to be a bit slower than normal, but maybe that's a good thing. Let's start off by looking at our components and what we need. So from the picture, we obviously have 2 wheels, not just one, and we have 2 motors. So the easiest way to duplicate these things is you can either use copy and paste, or you can use move and copy. So you can create a copy like so, and when you move it, it automatically makes a copy of it. I want to rotate this as well so that the 2 ends, the 2 places where the wheel is supposed to be, is kind of facing opposite directions. So as you can see, just like that. All right. Same thing with the wheel. Where's my wheel? The move and copy. So I'm just going to move this one like that. Oh, can't create a copy when you already moved it. Well, let's create a copy. Let's make another one. Let's rotate it around. Okay. So now we got our wheels. I'm going to show you some kind of more advanced things, but not really that advanced. But Fusion also has a great, as part of its kind of animation properties, it also has some aspects of physics, and when you move one object, it moves another type thing. So yeah. So when you select the component you want to copy, so like component 1, you can also rename it. It's probably a better thing to do. Make sure all your components are named. Go right click and you go to move and copy, move/copy. And once you have that, make sure you click the dialog box that says create copy. And then when you move it, it'll make a copy automatically like that. Any questions you have, just put it in the chat. I'm not gonna progress any faster than you want me to. Okay. So in terms of starting to model it, I want to join the wheel and the motor together because they're usually going to be together all the time anyway. So it'll give me some leeway in terms of how I'm going to structure my robot. And this is kind of the thought process when it comes to designing how everything's going to sit together. You can usually, when you're like for 317, when you're thinking of your design, usually it's like 3D stuff first. But maybe sometimes you have a bunch of components and you kind of want to just put them together in the best sort of way. So this is kind of, I'm going to kind of give you my my thinking process in terms of making like structures for all these components to sit in. So I'm going to show you this feature. It's called joints. And this allows you to join different components together. And as you can see, these are components. And you can join them together and then like animate them, or I just wanted to fit them together. So right now we're going to click on the circle of the inside of this wheel here. And it might be rotated around for you. And I'm going to click this circle here as well on the motor. And you'll see that, voila, wow, it just moved right into the place where I want it to be. And you can use these arrows to kind of fit it into place as much as you want. I'm going to get it pretty close. And you can also just like fine tune it by adjusting the numbers. So maybe I'll just leave it like 7. And you can see it moved. The whole thing moved, but you know, that's how it be. The order of which one you choose also matters. That's probably why the motor one moved and the wheel didn't move to the motor. It's probably because I should have moved the motor to the wheel. I mean the motor first and then the wheel, because maybe the first thing I click is the primary object. Anyway, let's test that theory with this part. So again, the joint. And by the way, when you scroll, it scrolls to the direction of your cursor. So you can kind of like fly around like that. That's usually like how I like to do it. And let's click this thing, zooming in. So just click that surface there. And clicking this surface here. And get that in right there. And I think I did 7 last time, so I'll do 7 again. Jeez. Yeah, and as you can see, it went to the motor this time. It's so weird. It like goes there and then it comes back. Oh, whatever. Okay. And now whenever you move things, they're together. Woo. Also, what you can do is you can actually change this joint to be whatever you want it to be in terms of motion. This is kind of unrelated to what we're doing, but you know, it's cool nevertheless. So you can make it get a motion here, and you can make it a revolute, which is probably what you're going to be using it for. So if you want to animate these things, you can give it this thing, and then you can kind of move it around in the animation tab. You can make your own animation by moving those joints around. So it's really just some good fun. Anyways. Okay. We're still structuring everything together. Let's just move the parts into where we want them, closer to where we want them. I wish I had my cube, man. It'll make things so much easier. See, Alex? All right. So we have, let's just move this. This is where we get a bit fiddly with moving things around, but it's okay. So let's try and make them as close as we can. This, my cube, man.
Stop quickly.
Maybe.
How important is the cube?
It just makes it a lot faster. Does cube work? Yeah, what is it? Okay. Okay, maybe you guys can like figure out how to get them aligned to like the picture while I restart my application. It's okay.
Still, that's so much better.
How are you, Peter?
Not bad. I'm very slow. How do you make this joint?
Yep. So click on the joint button at the top.
Well, it looks now that you go this now go to the and then you can that's the surface. Kind of with the right. With this.
No worries. All right, we're back. Hopefully everyone is. Oh, the cube's back. We're in business. Okay, let me open this back up. And this is recorded, by the way, so you know if you fall behind, there's no stress. You just watch the recording or just play around with it in your own time. All right. So remember when I said you want to snap the grid? You can turn these off, turn it back on. Oh, don't do that. Play with this. And we want to make it snap to a grid. So turn it off, turn it back on. Geez, that didn't work. What happened last time? There we go. So now the grid is like optimized to the bottom of viewing thing. So it looks kind of like the ground is the ground. The way I like to align things that might help is that if you look in specific planes, when you drag it, it only move in that plane. Like for example, if you're in 3D mode and you drag things around, you're kind of moving it in all three directions, and it's kind of hard to dictate where exactly it's going to go. So I like to orient things and position things kind of one plane at a time. So I'm doing it from the top plane right now. So this is the front. This is kind of the, ooh. If things are not coming together, make sure for the component you make it a rigid group. And always press capture position, it's fine. Press OK. And now all the components within that component will be the same. And let's just mute this one. So the Omni wheel goes at the back. I don't know if you made a robot like this, but this is kind of what I made in Eng 1000. Is just like two-wheeled robot with a spinny wheel at the back, just for, you know, balance sake. And let's have the battery. Where do we have the battery? You put the battery at the back like this, and maybe we rotated it around. Battery. Let's call this battery. Rotate this around. So this is what one of the benefits of doing CAD is. If you're not very good at visualizing your project, your products in 3 dimensions in your head, it's a lot easier to kind of figure it out using CAD software. Hey Maya. But yeah, just like figure it out, kind of like put the things where you want to put them. It doesn't have to be exactly how I put them. You can kind of find out the hard way how exactly I'm doing it. But this is kind of what I want to do it. You could have your battery like where this is, you could have your battery here. But when you think about placing your components, think about where the wires are going to go, right? And think about think about where your wires are going to go. So for example, my Arduino, so the power supply has to power both the Arduino and the motor driver. So it should be relatively close. Maybe, you know what? Maybe let's put the power supply in between them. Maybe that makes more sense. But then this port here, actually, not really. Yeah, then that means these wires also have to come through. So it's really up to you. So try and imagine where all the parts are going to go. So I know there's like probably going to be some PWM outputs from the Arduino into this motor driver. These little ports here will be connected to each motor, and the power supply will be connected to this power supply, and this power supply will also be connected to the Arduino. You also want to have some space for when you want to plug in your Arduino if you don't want to pull it out and in every time. So like in the picture that I sent to you, I left some gaps here for your wires to kind of like plug in so you can kind of download and upload sketches, Arduino sketches and things like that. Again, when I am moving things around, I like to do it in like in planes. So I'm starting with the top plane for now, and we're going to move into the next plane. And feel free to rotate things and stuff like that. But for now, I guess just try copy what I'm doing. Copy. All right. And when I'm thinking about this, I want to be, initially, I just want a flat board that kind of houses all the components, and all the components just sit on top of this board. And this one will be screwed below the board. Okay. So let's just think about having a gap here. Just like that, something like that. Oh wait, my bad. The board's here. Everything's sitting on top of the board here. Don't do that. This part might be the hardest part for you because it's kind of like requires you to imagine things that don't exist yet. But I'm imagining just a flat piece of board for now that'll have all these components on it. But what we can do is we can edit that board and kind of make it more three-dimensional and things like that. So when you've got that in place, we've got about 30 minutes left, so I might start to speed up things depending on how things go. But let's create that board now. And in the first part of the lesson, I kind of showed you how to create 3D objects from 2D planes. And that's exactly what we're going to do. But I want to have a plane that sits in between here. Or maybe you can either click on this and make something from it, but I'm going to use an offset plane just because I want to. There's many ways to do things, just like in life. So so this is how I'm going to do it. Okay. So I'm going to put a plane here in between the two. And using that plane. How you going, Peter? Okay. Go back to the when the motor driver is in one spot. Is it all in one spot right now?
No.
Like Control Z when it's all together.
Yes.
Yeah. When you get to that point, I'll re-explain how to kind of join them all together, and so you can move them easier.
Yeah, I just ignore the motor driver.
Okay, no worries. If you guys have that same problem and you're messing around with the motor drivers kind of like in pieces right now, make sure it's in one piece, and then go back to the driver. Where's the driver? And then just click rigid group here like this, and it'll make it so all the relative positions of all the components here will be like combined into one. You're basically grouping them together. Yeah. Sorry about that. I tried to make it simple, but I've missed some parts. All right. So back to the task at hand. We want to make this little board here. So let's make this board. So I'm in the sketch plane again. I'm going to rotate a bit. So this is like your character creator. And so you can have a bit of fun here. But for now, the objects you have, they don't have to be in the perfect position because we can use that joint tool to kind of lock everything in. All you really need is the dimensions of things. Like maybe for right now, I'm going to hide one of the wheels, hide one of the motors and wheels. Oh, because we can duplicate everything on this side to this side. And I'll show you that part of the sketch as well. So let's get started. I'm going to start off with just a simple rectangle, like as we did before, to kind of highlight everything we have. And it's good to make it symmetrical as well. So if it's 5 blocks wide, like how I have it here, to make it 5 blocks wide on the other side, and stretch it down like a decent amount, and we can shave away what we don't need as well later on. So simplest case, we have our board just like that. Boom. Now that you have a rectangle that surrounds most of your components, we can kind of add more design elements. So let's do that. I'm just going to make this rectangle a bit longer just by making another rectangle. And I'm going to make that kind of curve that we had earlier, that in that picture that I showed you earlier, with that that piece there. I've realized that I had the wheels a bit further back, so I'm just going to move this. Yo, I'm not allowed to move it. I have to go out of this sketch to move things. Okay. I'm gonna just finish that sketch for now, and I'm just gonna move this back a bit. Yeah, maybe like that. Okay. Sorry if this becomes too hard to follow. It's okay. Just put it in the chat if you want more time or anything like that. So we also have this timeline which allows you to go back in time. So if I didn't want to make that sketch anymore, and if I wanted to go to a position before I made that sketch, you could do that as well. But for right now, I'm just going to make another sketch on top of this sketch, which is honestly pretty messy. You shouldn't do that, but it's okay. We can forgive ourselves sometimes. It's all part of growing. It is. It's all about getting deep. Okay, so I clicked on the arc tool. 3-point arc. You can use this tool. It's a lovely tool. If you want to get spicy, but you can use the conic curve. My good friend Bradley says the conic curve looks better than the 3-point arc. Mathematically, it looks better. So you can either trust him or trust me. I don't really care. But here we go. And yo, my wheel's all the way back up there. All right, let's see what happens. It's just two different types of tools. It doesn't really matter. So play around with that. I just wanted to move this wheel back because I wanted to make it start from here. I can just. Okay, there we go. Okay, let's go to 3-point arc. Click on one side of the wheel and click on the imaginary other side of the wheel. Use the grid as a reference. So this is 3 blocks out from this wheel. So I'm going to put it 3 blocks out. And you can make it as big or just put it reasonably sized. Maybe I'll just put it there. Press OK. And I'm going to join it with a line like that as well. Right click, OK. And you can see here, this wheel's in the wrong spot, but I'll show you later. It doesn't really matter because we can move all those parts together. No worries. Another thing I'm going to do is I'm going to taper the back end. So that's just another, just drawing. Kind of like, just drawing a trapezoid for the back. I'll let you guys do that real quick. Okay, once you guys done that, how are we going, Peter? You need more time? Yeah, okay. And remember again, you can use the trim tool to kind of get rid of things that you don't entirely need. You'll see this warning because some locked constraints are unlocked because you've kind of removed some of the geometry, but that's okay. And this is where you can just be creative, man. You can make your own car, make it look all nice and stuff. Add your own fillets to make all the corners rounder or something like that. You can apply these basically everywhere. Maybe I'll put a little short, smaller one here, like that. If you're a dimension freak, you can type it all in yourself and make sure everything's the same. Each person has their own level of, OCD per se, to how they want everything to be symmetrical and all that. So, but we can find beauty in the imperfections, if you like. Welcome to Philosophy 101 with Miguel Pacheco. I'm hijacking the course. Okay. Once you guys done that, we can kind of we can now extrude this part. So this is our little board here. This is the advantage of 3D printing in CAD. You can kind of make more complex shapes with this software. And when we do it, I'm going to put 2.5 because that's what I feel like. And why is this cutting? I don't know why it's cutting, but we don't want it to cut. We want to make a new component. So this is a brand new component we're making, which is the board. Okay. And you can click OK. And you'll see that it will appear right here. You can name this board or baseboard. And boom, look at that. Beautiful. You can also get that part back and kind of move it to a better spot if you feel like it. But there you go. We've already have something cool that you could, even if you want to just leave it like this, just having a cool base plate for your design is just fine. But I'm going to show you some other things we can do with it. For example, you can put as much bullshit as you want in the sketch. Yeah. It's just if you're going to use it, like if you're going to pull it three-dimensionally, that you can't do anything. It won't do anything. So it doesn't really matter unless it's like you put a hole in your piece that you didn't want it to have. Yeah. Okay. And now that you have your board, I'm going to show you another really cool tool in terms of how we're going to set these objects into our board. In some ways that, well, I'll show you pretty much one of my favorite tools for doing that as well. So this LCD screen can basically anywhere, but for now I want it to be on top here, on top of like where the roof is going to be. But I don't really want to look at that right now, so I'm going to just hide it with the eye tool here, the visibility tool. Get rid of that. I don't want to see that. Okay. So we're going to create another sketch on top of our base plate. Create sketch. Capture position. Okay. So what we have here. Okay, cancel. I changed my mind. I want to move some things around. I want to move this one a bit closer to the edge here. so that I'll have easy access to when I plug things in. So this is just some things you think about when you design, and this is why it's very fun to do these things in CAD first before you start doing things. So because everything's so editable, right? You can just change things on the fly. If I really wanted to change the back end of this, I could change it here, and don't worry about implications in real life because I haven't actually made it yet. So I'm happy with the position of my components now. Yeah, I think it's all right. I think that'll do. Maybe I'll rotate this one around. And they don't have to exactly be in the spot you want them to, depending on how tight everything is. Right now, I've got a lot of space, so I don't really have to worry about being perfect too much. And you know, when I make this in real life, when it's printed, 3D printed, there's going to be small imperfections, like this might be a bit thicker than it is in real life, things like that. So on the grand scheme of things, don't worry too much. Okay. Now I'm going to lock, I want to make the base plate hospitable for these components to sit on and make them kind of lock in without gluing them or anything like that. So what my plan is using these screw holes, I'm going to add little columns to kind of, so I can just slot it in right in there when I make it. Little columns there. And if you even see on this battery pack here, we'll just move it out of the way real quick. You can see there's also holes over here that we can use. So we can put little columns in there as well, to make it sit in the spot that we want. Similarly, we can use this. We can use kind of like the corners of this and this to kind of make sure it's in the right spot when we place this motor down. So we can kind of use these geometry here to kind of make it sit in. So what I'm going to do is I'm going to create the sketch, capture position, and I'm going to use my favorite tool, which is hidden in the depths. It's called project. All right. I'm going to pin this to the toolbar, so you can click on these 3 dots, pin to toolbar, and now you have this project tool here. And what this does, it allows us to basically click faces and bodies and things like that, and it'll project down onto a 2D surface. So I want to project all these components onto our 2D plane that we have here, and it'll come up in purple. So now I can directly reference where the positions of these components are, without mangling about their 3D-ness. So I can get rid of the battery, get rid of the Arduino, the motor, all this stuff I don't really want to see. And now we can kind of just see what those components look like in 2 dimensions. Oh yeah, sorry. So going back, what we want to do is create project, and there's a selection filter here. Sorry, I didn't say this, but you can choose either faces or I can choose bodies. So I clicked on bodies because I don't want to go around and click every side of this thing. Kind of just want to select everything. It's okay. I'll make sure you just click the housing of the battery pack and the base plate of that thing right there. And okay. And then you can just hide everything else besides the base plate, and you're left with these little imprints. Okay, let's make those columns. So an easy, if you wanted to be simple and easy, you could just click on these columns and then go to solid and then go to extrude them and extrude them up some amount. But from experience, you don't want to make it so like you want to give some leeway for the 3D printer because it'll kind of be bigger than what you have in CAD. So what I'm going to do is use the offset tool. So under modify, next to your trim, you're going to have this offset tool. And offset, like it's shown in the picture, if I select a curve, I can make a simplified version of it, or change the dimensions of it and make a copy of it. So in this way, I can make smaller circles that I can extrude and that I know will not interfere with the actual component when it's printed. So I'm just going to make that minus 0.5. And this is where we get a bit tedious and we have to do it for every circle that we see here. If you don't want to do that, you can just, just click on the circle and press extrude. Maybe we'll do that because I don't want to put you guys to this torture. But this is, you got to have some labor, bit of labor and love if you want to get things right. But for now, we won't worry about that. Let's also think about how we're going to house this motor in. So if you remember what the motor looks like and how it's going to sit in, this is another beauty of having CAD is that you get to look in the details that you wouldn't really look at in your brain. But I want to have a little housing here, which means kind of just like edges to kind of hold this piece in place. And similarly for this edge, and the idea is when these two faces, these two faces, but imagine I click on the right ones. This one, and this one, and this one. Imagine when I extrude this up, it's gonna be like good guidelines or a good kind of like cage for exactly where this little piece is gonna slid into. And obviously having your offsets here will help a lot. I might make a bit more of an offset. So there's a bit of leeway in terms of like how it's going to sit. And that's really up to you guys and a bit of a trial and error with your own 3D printer or the 3D printer that the uni has. Okay, so that's a cool part. But I wanted to have it over here and I want it to be in the exact same place. So I'm going to show you another cool tool called the mirror tool. And this mirror tool, you'll need a mirror. But we're going to make the mirror. And the mirror is just a line of reference. So everything on this side of this line can be reflected onto this side. Okay. So I'm going to click the mirror tool. I'm going to highlight what I want to, take over to the other side. I'm going to press the mirror line and I'm going to click right here. So now you can see that everything is going to come through over here. And I realized earlier that I shouldn't have projected this in because it makes it all messy, but it's okay. So you do that and boom. So now you have exactly this side and this side. And when you place that motor there in real life, it's going to be in the exact same position as this one. Cool. All right, now let's make these bad boys reality. So I'm just going to click on all the faces that I know I'll need. This one, this one. This one. I'm just shift clicking here. It's like any other tool. Ooh. If it helps, you really want to zoom in a lot to get the faces and not the lines. It might actually be better to use the finish the sketch and then click extrude and then click just the faces. But this is how I like to do it. There's some little shortcuts you'll realize that'll make the whole process faster for you. Like, see, I'm still in the sketch phase, and usually you want to press finish sketch before you start making things 3D. But if you have everything selected here anyway, you can just go to solid, and then you can just press extrude, and it just finishes the sketch as well. But you're now also in the extrude space. Okay. Just like that. Okay, let's make that a bit taller. And there you go. And now everything has a place to go. So your Arduino is going to be locked in. The battery probably doesn't need to be that long, but we can adjust that. The driver has a place to sit. But there's one thing that I missed as well. With the battery, see, my part is going through, so I didn't want everything to be the same height. I actually wanted this one, these ones to be a bit lower. So what we can do is we can hide all this, and we can press extrude again, and we can just remove some of the height from these things. Just make it a bit shorter. I'm going to turn on that motor for a reference point. Just make it a bit shorter, maybe 2.5. 200. 4. So this is where the guessing checking comes in. I'm sure you do that for all your maths tests and all that anyway, so it's all good. Experienced. Okay. I'm just looking if it's intersecting or not. Maybe I'll just go one more. Okay. They're just guidelines anyways. Okay. Ooh. So now you have that in place, and hopefully there should be some good guardrails when you print it for where your components should be. That's just from experience doing this. We only have a couple minutes, 10 minutes remaining, so I'm just going to speed run everything that I'm doing. You don't have to follow along, but I kind of give you some full speed Migu action. Okay, so now I want to make these walls. Let's make these walls. So I'm going to create a sketch on here. And I want to, what is this? What I want to do? I want to offset. This is a neat little offset tool that we used last time. So these are the walls of the thing that we're doing. So maybe I'll make them 2.5 as well, same thickness as our base plate. And there's a couple of things I need to do. Like, for example, I don't want to include this part of the wall. And maybe this part. Yeah. I don't want to include that part because it'll infringe on the motor. I want some space for these two parts to go to. Maybe we'll do it one at a time. And knowing Fusion as well, if you're artistic, it's pretty much the same as every other. It's quite similar to other modeling softwares, and it'll help you get that three-dimensional kind of view on things. It definitely helped me in terms of my visualization, just in general life as well. Learning how to use CAD kind of makes you think about, engineering things a bit better, because you have all these processes that have been ingrained in learning this software that you can think about things in real life with. So I can make these walls that go up. And it's up to you on how tall you want to make them. Let's just make them that high. Okay. Make sure you press join, so it joins onto the baseboard. Boom. And now you have a little enclosure, so people can't see all the nasty electronics and all your spaghetti wires that you have in there. People won't be able to see that. It's always good. And we'll make a quick lid as well. How do we make a lid? Same thing again. Just click on the surface that you want to start it from. And we're going to use the project tool like we've been using before to project the base, because I want the top to be the same as the bottom. Press OK. And I also want to make a hole for this LCD to be in. And as you can see, it's kind of off center, but you know what? That's okay. So we can use the project tool again. And maybe I don't want to select the whole body because it doesn't give me what I want, but maybe I just want these corners here for what's going to be peeking out, because I kind of want to drill this section of I want to place this section of the LCD screen underneath the lid. So from the top, you'll only be able to see this top section, if that makes any sense. You'll know what I mean when I make it. Okay, now that you have that's a little hole there. I'm going to add some leeway. I didn't project everything. Maybe I didn't. Okay. Yep, that'll do. Okay. And I'll finish this sketch. Now I'll select everything, and I'm going to do exactly what we did every other time and just extrude up. And I'll make this 2.5 as well, so 2.5 millimeters. Make sure you delete what's already there. And I don't want to join it this time. I want to make a new component, because this part will be able to remove from the whole base itself, so we can, edit it. So we can take it off when we need to and change the batteries and all that. You know what I mean? And ideally, you'd want to. So this is what I meant by why I wanted to just have this part. Oh, maybe I should have that part as well. Yeah, probably. But I'm kind of under the time pressure now. So I wanted to just make it sit like that. Okay, so you only see that front part. Beautiful. All right. And when you go through this, we have 5 minutes left, so I'm going to show you some more advanced features and what you could do later on. So another part when you have to do that is the screw holes as well. So that's the same as just using the project tool, as I said, and then just extruding those holes through, cutting those holes. Same goes with this one. Cutting those holes through. I forgot to do that earlier. But I want to show you another part, which is the rendering side of things. Now again, look at that juicy, you know what, that's a router. That's a wood router. I remember making that in year 9. All right, here we go. So this is where we can get a bit more creative with how we present our little robot. And this is what's good for presentations, things like that. So I can go to appearance. And I don't even know if SolidWorks has this. This is why I like Fusion, because it has so much things you can do with your objects. So if you go to like plastic, you want some, maybe we're printing it white, and like how I did it before. There's so many options you could have. Maybe I want some transparent top, so I can kind of appreciate my spaghetti wires inside. Could have it clear. Could have it amber or whatever. Amber is the answer. But yeah, that's pretty much it. And if I like it how it is right now, I can do an in-canvas render or a cloud render. And I can also set up the environment. I'll just show you some cool stuff right now. It's my favorite part. I'm going to download this. Tony. I'm sorry. It's probably only a couple megabytes. You can drag this in. Okay, now we're getting some scenic lighting, but that's not it. I put the environment in. And look, we're in here. But look, the ground plane is not on the ground, but you can flatten the ground. And it's to scale. Now we're talking. So this is some of the beauty. You can even like go online and import your own kind of backgrounds, which I've done before, like tabletops, things like this. So especially being online last year, you couldn't actually make it if I didn't have a 3D printer. So this is kind of like a good alternative to kind of showing your solution. As well as if you run out of time to 3D print your model and things like that, you can always have this, and you could kind of have it for your presentation, for your reports. It'll just make everything much more like professional as well. So, for example, when you're explaining different parts and different components you have, you can kind of show them kind of like the inner workings of what you have. Take some pictures, and there's some ways to, like, for example, let's try in-canvas render, and it'll start from very pixelated, but over time it'll be a very high quality looking picture, and you can play around lighting, things like that, and it'll look good.
Very good.
Yeah, so I've made some. Yeah, the background just makes it alive, right? But that's some cool stuff. I've given you pretty much. It's definitely been a crash course. You look how that metal looks on that Arduino. It just looks so good. And the plastic looks real. So hopefully this was helpful for you guys. For you 2 other people that have stayed along with us. Thank you, Ryan, and thank you, Nicholas. And thank you, Peter, and everyone else who's watching the recording. Hopefully this was helpful. And no worries.
Thank you, Miguel. That was awesome.
Thank you. Thank you, Maya, for joining and absorbing. All right, feel free to go. I think that's it. If you want a part 2 of this, let us know. Maybe the 3D modeling.
3D modeling, but looked like it was really well set up to print. Sort of thing.
Yeah, exactly. So if you know a thing or two about printing,
Stop them.
I will stop the recording. How do you stop recording? Oh no, that's not it. That is it. Oh, cool.